All right, part 3, find the limit of radical expressions. So we talked about this last time. If you need help, there's a few sections that kind of review this stuff. Okay, so this time we're doing or simplifying radical expressions. So remember we want to rationalize the radical wherever it is, numerator, denominator, it doesn't matter. The idea is we want to try and get rid of the 0 over 0 term. Okay. These questions are designed to yield a pair of factors that just cancel, and I know what you guys are thinking, oh, how often is this ever going to happen, or whatever. Okay, it seems like it's a huge coincidence that there's always going to be a factor that cancels, but this limit process is just part of, or was one of the procedures we use to find something called a derivative. Okay, we discussed that early in Unit 3, and this is just one of the ways to do it. So even though it seems like a huge coincidence, it's actually designed to do exactly that, to cancel it off. So it's going to happen more rather than less. Anyways, so example 1. Okay, so let's say we have this limit as x approaches 0, okay, of x plus 1 square rooted minus 1 over x. Again, the first idea is to substitute the 0 in. So 0 plus 1 is 1. Square root of 1 is 1. 1 minus 1 is 0 over 0. So, okay, this is a 0 over 0 limit. Okay, imagine that. All right, so next up, okay, so we want to multiply this. Remember, it's a binomial radical with an extra 1 here. So we want to multiply this by the conjugate. So x plus 1 square rooted plus 1. Whatever you do to the bottom, do to the top, or whatever you do to the top, do to the bottom. Okay, now remember, when this works out, so that's the limit as x approaches 0. Okay, so remember, if this was a FOIL, okay, remember having the conjugate pair just eliminates the O and the I. So this is going to be this, the square root of x plus 1 times the square root of x plus 1 is just x plus 1, right? The square roots cancel. Okay, and then we're going to get a plus 1 times square root x plus 1 and a minus 1 times square root x plus 1. So those are going to cancel. That's the O and the I. And then the L is just minus 1. Okay, and then of course we get x. We are not going to bother multiplying this through. Have faith. Okay. Oh, look what happens now. So limit as x approaches 0, x plus 1 minus 1. Okay, well that's just x. Okay, over x, square root x plus 1 plus 1. Okay, oh look, the two x's cancel. Wait a sec, there's the 0 over 0 part. So limit as x approaches 0. Remember, when everything on the top or the bottom cancels, we leave a 1 behind. So root x plus 1 plus 1. Now what this does, now that we've canceled off the 0 over 0, now we just put in the 0 for the x. Okay, so we get 1 on top, and then 0 plus 1 is 1. Square root of 1 is 1. So 1 plus 1 is 2. So the 0 over 0 goes away, and what's left yields us a limit of 1/2. So as x approaches 0, y approaches 1/2. Okay, before you hit rewind, okay, this one is pretty much the same idea. Yeah, so have a look again. So we put the 0 in. 0 plus 4 is 4. Square root of 4 is 2. 2 minus 2 is 0. And then x is 0. So 0 over 0 again. Okay, well, like I said, we've designed it to kind of be that way, so all good. All right, so it's a 0 over 0 limit. So now we multiply by the conjugate. So that's going to be x plus 4 plus 2. So then x plus 4 plus 2. Okay, same kind of deal. Limit x approaches 0. Okay, so this is going to be root x plus 4 times root x plus 4 is just x plus 4. Okay, the O and the I are going to cancel, and then we get this negative 2 times positive 2, which is minus 4. Okay, x plus 4 plus 2. Okay, oh look, the positive and negative 4 cancel off again. leaving us with just the limit as x approaches 0 of x over x root x plus 4 plus 2. Okay, so the x's cancel, leaving us with the limit as x approaches 0 of 1 over x plus 4 plus 2. Okay, so now that the 0 over 0 is canceled off, we put that 0 into the remaining x, and you get 1 over, okay, 0 plus 4 is 4, square root of 4 is 2, so 2 plus 2 is 4. So there is our limit. Awesome. Okay, and then the last one, okay, a little bit different, but let's give it a go. So x equals 6, put that in. So 6 plus 3 is 9. Square root of 9 is 3, so this is 3 minus 3 equals 0. And then 6 squared is 36. 36 minus 36 is 0. So this really is a 0 over 0 limit. Okay, fair enough. Again, designed that way, but we should always check because, like I said, some kids never bother and end up doing a bunch of factoring and stuff when you really don't need to. So, same kind of idea here. We're going to multiply by the conjugate, so x plus 3 plus 3, right? And what makes it the conjugate is this sign changing. It's not the part that's under the root, so not that one. Okay, it's this guy here that's super important. Okay, so we change that guy's sign, so x plus 3 plus 3. Now look what happens. So again, we FOIL the top, which is conjugate pair. So it's still the limit as x approaches 6. So this is going to be x plus 3. The roots are going to cancel. Okay, x plus 3, and then negative 3 times positive 3 is negative 9. Okay, all over x squared minus 36. And we're going to factor that here in just a minute, but we'll get there. Plus 3. So this works out to x approaches 6. So this top part is just x minus 6. Now the bottom, we notice that can factor, so that's x plus 6. That's a difference of squares, right? X plus 6, x minus 6, square root of x plus 3 plus 3. Okay, oh look, the x minus 6's cancel. Wow. So limit as x approaches 6 of 1 over x plus 6 square root of x plus 3 plus 3. Okay, so looking at how that plays out, so the 0 over 0 is gone, so we just substitute the 6 in. So this is 1 over 6 plus 6 is 12. Okay, and then 6 plus 3 is 9. Square root of 9 is 3. 3 plus 3 is 6. 12 times 6. Okay, so and then 12 times 6 is 72. So this is just 1 over 72. So that's our limit. Thanks, guys. Remember, if you have any questions or comments or want to talk, just give me a call or a text or hang out with me over Google. It's all good. Thanks again. Talk to you later.